Look at this. The Flint campus gets to close at 2. We gotta wait till 3. All right, well, we'll get started here. Let's see, let's look at the syllabus, see where we're at here. We're on week 6. 1 week from today is quiz 2. Does that sound right?
Yes.
1 week from today, okay. Today has to include some review involved, but then we end with type 1 and type 2 error, but the review should be good, pretty good. Here's what I want to start with. I want to talk about the instructions. Don't forget, I don't want any confusion. Yes, week 6 homework is due in 5 days, Monday the 17th. Week 6 homework is due. There's 3 problems on the homework. Let's just look at it real quick. First one's asking you to use the p-value approach. The second one's asking you to use the critical value approach. And the third one's asking you to use the confidence interval approach. And they're all 3 related to proportions because this week's all about proportions. So you don't need to try to figure out if this is Z or T or anything because you know it's proportions. You just got to focus on doing the particular approach that it's asking you to do. That's kind of the key. That's why when I post these answers on Tuesday next week, these are going to be some good answers to have ready to go for the quiz because you have every single approach there if you happen to have a proportion. That was interesting. You could get out even earlier. All right, so I want to start with this. I want you to tell me if you'd use Z or T. Z or T. Ready? Local brewery wishes to ensure an average of 12 ounces of beer is used to fill each bottle. In order to analyze the accuracy of the bottling process, the bottler takes a random sample of 48 bottles. The sample mean weight and the sample standard deviation of the bottles are 11.8 ounces, 0.8 ounces respectively. Z or T? T it is. T it is. One tail or two tail?
Two tail.
Why two tail?
Because the average of 12 ounces is going to be, the hypothesis is going to be equal to.
Well, hang on. It does say average of 12 ounces, but in order to analyze is the key. Say it again. The accuracy. It doesn't say we're analyzing if it's overfilling. We're not analyzing if it's underfilling. It's just accuracy. That's how you know it's two tail. It could be either direction we're testing. All right. This is a T. I want to do a setup. Let's pretend. Hit me with some numbers. I want to pretend as if we're having to solve this using the p-value. So let's pretend I got to find my test statistic. How do I start? What's my numerator?
Numerator is going to be 11.8 minus.
Very
12.
good. 11.8 minus what?
12.
12 it is. There's my numerator. Divided by. I got to take a look. Hang on. Go ahead.
So we're going to do the standard deviation.
Standard deviation. There we go.
Of 11.8. I mean.
Over what's the, how many?
0.8.
How many? No, 0.8, but how many pounds?
Divided by the square root.
48. Square root of 48. There we go. There's our test statistic T. There's the setup. There's where most of the points are. All we did is we recognize this. We're assuming, we're pretending as if it says p-value. Now I want to, let's see, where is it? Oh, I didn't open it? Darn. Hang on, well, let's just check. It says p-value. I got notes right here. Okay. We're doing the p-value right now. Equals T, D, I, S, T, parentheses. Did you say this is one tail or two tail? You said two tail? So it says it's two tail. Let me just stare at this for a second. All set. We don't know what this equals right now, but this is what's going to be the first number. What's going to be the second number?
47.
What is it?
47.
Very good. 47 degrees of freedom. What's the third number?
2.
2 it is because it's two tail. Very good. There it is. We found now our p-value. We got this. This question's not finished. It didn't give us what the significance is, but we would be comparing that p-value to that significance. Let's assume that p-value is a little greater than the significance. Do we reject or not reject? Let's pretend the p-value is a little greater than the significance. Do we reject or not reject? The p-value is greater than the significance.
Reject.
Not reject. Don't forget, with p-value, you're making the comparison with significance. If it's less than significance, you must reject. If it's greater than or equal to significance, you cannot reject. All right, there's our first one. We made it through, even though I need more participation on these easy questions. This is all about quiz 2. I'm trying to make sure you guys ace quiz 2, no matter how hard I make it. At least the problems on it. I don't know about the multiple choice. All right, here we go. The G, how far can I go without showing another question? Right there. The grade point average, let me make this bigger. Let's see that. There we go. Grade point average of business students, can't show the next one. Grade point average of business students in the university is known to be normally distributed. A random sample of 20 business students results in a mean of 3.12 and a standard deviation of 0.19. Z or T? T it is, because that's the sample standard deviation. Very good, this is another T. Let's pretend we're gonna do, this time we're gonna do confidence interval. Oh, let's think about this, confidence interval. Confidence interval always starts with what number would I use off of here? Hang on, we don't even have a hypothesized number here, do we? This is very little information here. Very little information. We know it's a T, and we don't have enough information to do the confidence interval because we don't have the hypothesized number. All this is telling us is that we know we would use T because we have the sample standard deviation. All right, so we can't even put this one on the board.
So if we like saw a question like this on a quiz,
We
would
don't
it
have
just
to-
be
we
like
don't have
Z or T?
significance.
Yeah, if you saw a question like this, probably multiple choice, would you be using Z or T, the different things? Because there isn't even a hypothesized number there. This question wouldn't be on the next quiz no matter what, so you can kind of count on that not being there. Okay, here's this one. Yeah, a little farther. A researcher wants to determine if the population mean is greater than 45. A random sample of 36 observation yields a sample mean of 47. Assume the population standard deviation is 8. Z or T?
T.
Z it is, because of population standard deviation. Population standard deviation. Go ahead.
For number 2, we can't do that because we don't have the hypothesized.
Yeah, I didn't put one in the story there, hypothesized to compare the 3.12. So, just ignore that. I originally wrote this, that all we were gonna do is Z or T. Then, now I'm, doing an audible here, I'm just saying, hey, why don't we take it a step further and maybe set these up a little bit, because that might help. Different approaches, using different approaches. Now, this one's gonna be a Z. It's a mean and a standard deviation, and I don't think we've seen enough confidence intervals set up with something like this. So I'm gonna set this up confidence interval. I don't think we've seen enough of them for me to put you guys on the spot. But you can, if you look at your notes for confidence interval, when we have the population standard deviation, you're gonna use the sample mean to start with. So is that 47? 47 plus and minus, this is gonna be the critical, you told me, Z times, now on the what's gonna be on the right side here is gonna be the standard deviation, which is 8, over the square root of the sample size, which is 36, I think, is that right? 36, I like to put this in parentheses. There it is. There's the setup, but you'd have a number here. So our first step is to find that critical Z, and I just want to show you, I have the critical Z formulas ready to go right here. Boom, look at that down here, critical Z right there, norm S, so this would go equals norm dot S dot I N V parentheses. The rule says put confidence there, but if it has to be two-tail, put the confidence plus have significance. Let's go back and look and see if it's one-tail or two-tail. I think I remember the first sentence told me whether it's one-tail or two-tail. Again, where is this? Is this it? No, this isn't it. Oh, she says one-tail. Here we go. A researcher wants to determine if the population mean is greater than 45. One-tail or two-tail? One-tail it is. So the rule said, what did the rule say? It said if it's two-tail, if it's one-tail, you would use confidence only. So this doesn't give us, darn, it doesn't give us a significant. I'm gonna make one up right now on the spot. Let's just pretend it said 5% significant. So what am I gonna put here? 0. What? 95. There it is. And whatever this ends up equaling would go right there. All right, now let's pretend we did all this. We found our upper interval and
Lower.
the lower. We got it. My question for you is, what will we be comparing with this upper and lower interval numbers? What off this information would we use to compare? The hypothesized mean, which is what though?
Hypothesis mean is going to be 45.
45. 45, because 47 is our sample result. We're comparing it to the 45. We're trying to see if 47 is greater than 45. So the alternative hypothesis, which is easy to write, would be this is a mean greater than 45, and the alternative would be mean
Less than 45.
less than equal to 45. Same number on this quiz. These hypotheses have to have the same number, both null and alternative. Look at you guys, I'm drilling this into you to the point to where you're all gonna ace this quiz. You're gonna ace it as far as the problems at least. I don't know about multiple choice.
Where do you get that .95 from?
This point 95? This point 95 is, I said hypothetically, let's pretend it says 5% significance. It doesn't say it though. I know, yeah. So just pretending it says 5% significance, we would use the confidence because we knew it was one tail. And then whatever we get there, we put there, we get the upper and lower. All right, let's do the next one. I'll leave this for a second. Last year, 50% of M&M Inc. employees are female. It is believed that there's been a reduction in the percentage of females in the company. This year, in a random sample of 400 employees, 180 were female. Z or T? Not all at once, we're recording. I'm sorry, what is it?
T?
T, you said? What kind of standard deviation is there? There isn't one, so this is what? Z. Z, it's a proportion, there's no standard deviation. Even if you don't recognize this proportion, when it literally gave you, what was the percentage? 50%. And right in the first sentence, even if you didn't recognize that, at least recognize it had no standard deviation. And so you know it's a Z proportion problem. I'm gonna switch these to P's or proportions right here. Hang on. Proportion, that's proportion, it's hard to tell. Proportion, and now I'm gonna read it again. Last year, 50% of the employees were female. It's believed that there has been a reduction in the percentage of females. We're trying to prove that there's been a reduction, so the proportion is less than 0.50. This one then would be greater than equal 0.50. There you go. There it is. Let me get this out of here. Hang on now. This is a proportion. This is just like our homework. On the homework this week, you got to do. Hey, that's enough. That's enough. Okay, you got to do all three approaches: the p-value approach, the confidence or critical value approach, and the confidence interval approach. Here's a perfect example of proportion. Right now, I'm ready to set it up. What approach do you think would be best for you to see right now? P-value, critical value, or confidence interval? I hear a confidence interval. Here we go, confidence interval. There we go. I want to start then with my critical value this time. Equals norm dot S dot IMV parenthesis. Hang on, critical value. I don't have the rule memorized. You guys got your notes out. Critical value, this would be, is it one tail or two tail? Let me read again. The reduction, there you go. You guys said it was one tail, so we got to use the confidence here. Did it give us the significance? We got to make one up again, David. You make it up for me on this one.
10%.
We're doing a 10% significance. So what's going to be in the parentheses here for this critical value? 0.9 what? 90. There's no reason to add half the significance to it because it's not a two tail, it's a one tail. So there's no reason to add half the significance to it. There we go. Someone give me that critical value as I start to write this confidence interval. The confidence interval has got to be, oh, we haven't got it. 180 out of 400. 180 out of 400. Someone's going to get that. Plus and minus. What's this? What's this critical value here? 1.281 or 2? 1.5, then it's 2. We got to use, if the next digit's a 5, oh, I can go another digit, I see your point. I'm going right here, 2. All right, so 1.282, here's the tough part. times. Now, this is the tough part to remember. The hypothesized proportion goes in the right-hand side. Not the sample proportion like we have to start with here. The hypothesized. This is the tricky part of this one. That tricks me even sometimes. And the hypothesized proportion is the 50%. So this is gonna be 0.50 times 1 minus 0.50 over, what's the sample size here? 400, and then you gotta put a square root over the whole thing. There's the setup. Now, this is gonna end up giving me, I'm gonna show 2 detailed calculations along the way, and then I'm also gonna get the upper and lower intervals based on this. Anybody got this 180 divided by 400? Is it a 0.38? No, it's not 0.45. Is it? Oh, sorry, 0.45. 0.45. 0.45 plus and minus this whole thing here. We get an upper and lower. What is it we're comparing that upper and lower interval with? What number are we going to use to say, hey, does it fit or not fit? The 0.50. The hypothesized proportion. We're going to see if 0.50 fits between here or not, yes or no. And if it does fit between there, if 0.50 does fit between there, do we reject or not reject?
Not reject.
Not reject. If it fits in the interval, we cannot reject. You got it.
So we would have.
All right. We have one more? I think we got at least one more. Oop, we got 2 more. This one looks like a short one. We may not be able to set this one up. We'll see. We draw a random sample of 28 from a normal population with a variance of 2.1. Don't let that variance scare you. Do not let that variance scare you. I can hear you from here. Do not let that scare you. We all know what the variance is. It's just a disguise. It's like a costume. It's like Halloween. We know what it is. If the sample mean of 15.3, what is the 99% confidence interval for the population mean? Ooh, we got a lot of information here. We don't have, what we don't have though is we don't have a hypothesized number up there. So we can't figure out if this is one tail. Well, can we figure out? We can't figure out if it's one tail or 2 tail, but we can figure out if we're using Z or T. Are we using Z or T? Z it is. Why are we using Z? Population what? Population variance, which is really the population standard deviation. What do we have to do to the variance to get to the standard deviations? Square root it. Square root 2.1 and you'll have the standard deviation. Is that right, or did I say it backwards? Are you supposed to square it? Square root it or square it? Go back to your 301 memory. Square root it? Okay, square root 2.1. So that'd be one of your first steps to get the standard deviation. We would have to have the hypothesized mean though to be able to know if this is 1 tail or 2 tail, to compare it with, to set it up and everything. But you are correct, because we have that population variance, this would be a Z. Okay, we got one more. I think there's enough information on this one, we can set this one up. Oh, we got 2 more. What? Crazy. How can that be? Oh, it keeps moving, hang on. Last year, a soft drink manufacturer had 21% of the market. In order to increase their proportion of the market, the manufacturer has introduced a new flavor into their soft drinks. A sample of 400 individuals participated in a taste test, and 100 indicated they liked the taste. We are interested in determining if more than 21% of the population will like the new soft drink. Z or T? Z it is, but why Z though? No standard deviation, it's a proportion. Is this a 1 tail or 2 tail? It's a 1 tail. We're trying, it says right there, we're trying to determine if it's more than 21%. So look, I'm just right now, our whole thing is to see if it's more than 0.21. So no, this would be less than equal 0.21. There's that. Let me get all of this off of here. Okay, this is a proportion again. We just did confidence interval for proportion. So this time let's use critical value. We'll use critical value this time. Let's start with critical value. No, we can't do that. We gotta get our test statistic, right? So our test statistic. Do we have a sample? A 400 indicated 100 out of 400, which is 25%. is it? 100 divided by 400 is 25%? So our sample is 0.25 minus the hypothesized 0.21, right? Am I right? I'm second guessing myself. What is gonna be in the denominator when we get the test statistic, the 0.25 or the 0.21?
0.21,
Why the 0.21?
because that's the hypothesis.
That's right, the hypothesized proportion has to be in the denominator, which is the 0.21 times 1 minus the 0.21 over the sample size of 400, square root this whole thing. This is going to equal Z test statistic. There it is. Now, once we have that test statistic, we're going to put it equals NORM. We're doing critical value, is that right? Critical value, SINV. Let me go back to the instructions. Hang on, almost there. You guys have yours? No, you
We don't
don't.
know
Okay.
if it's 1 tail, 2, or it's just
Hang
1 tail.
on, right here. Here it is. You want, let me get this just right. You may, because I want to show you what I did here. I went ahead and put together in words the setup for confidence interval for every one of the 3 possibilities. Mean with the population standard deviation, mean with the sample standard deviation, proportion with no standard deviation. There's the confidence interval setup for all 3 of them. Down below is because each of these setups have to have the critical value. Here is the Excel equation to find the critical value. We happen to be doing one with the critical value here, so I wanted to look at this equation right here, which is the top one. It says use confidence unless it's a 2-tail. This is a 1-tail, so we could just use the confidence. Let's go back to the problem. Did anybody got this? Everybody got a picture of this? So you have this, get a picture of this, zoom in on it, get a nice clear picture of this. This is a nice shortcut, because I put it in words, each confidence interval. So if you know the instructions say use confidence interval, there's your 3 equations right there. It's one of those 3. Unless it says use Excel only.
Will we put this on Canvas?
No, that's the advantage of showing up today. If you send me an email and remind me, I might be able to put it. Alright, so here we go again. 21% is what we're trying to test. If it's more than 21%, we got this whole thing. We get a Z. What's the confidence? Is it even on there? Darn. David, you gotta give us a significance. 20% significance, that's a big significance. This is a 1-tail, so what does it say to do if it's a 1-tail? Is it what?
It's just the company.
Just the confidence? So what would be in here if we're using 20% significance? 0.80 it is. That would give us the critical value, or the critical value, which we would compare this test statistic to the critical value. Don't forget, I like putting plus minus that critical value, so that then we say, hey, is that test statistic, let's pretend that test statistic landed outside the plus and minus critical value. Do we end up rejecting or not rejecting? Rejecting. If our test statistics on the outside of those critical values, we must reject. If our test statistics on the inside, we can't reject.
So we have sufficient evidence that we are going to.
Yeah, well, that's a good call. Let's jump to those right now. I want to help remind you I want to show you some examples of sentences. That final sentence I asked for, that some of you left off on the in-class assignment, I want you to see some examples of final sentences so you can see how they're written. Without even knowing this story, without even knowing whether this is a reject or not reject, I'm going to read the final sentence to you, and you tell me, do you think this was a problem that got rejected or not rejected? And try not to read it to find the answer right there, but here it is. The sample data does not the sample data does not support the research analyst's claim that the average back-to-school spending differs from 606.40 per family this year. Not reject. Basically, that sentence is trying to say the researcher was trying to prove that this is different, and the evidence didn't support it. So it really is right around 606.40 according to the sample data. Anyway, you saw the kind of wording it is. Let me show. I highlighted some other ones. Didn't expect that to happen. I think we passed a couple, but here's another one. At the 5% significance level, we conclude that the average study time at a university is less than the 1961 average of 24 hours per week. I think this is a rejected null hypothesis, and the point it's trying to make there is that we proved that it was less than 24 hours per week, which was probably what the alternative hypothesis was. all right, without passing a whole bunch of them, see, let's go to the next one. Says, at 5% significance level, we cannot conclude that the mean study time of students at the university is different from today's national average of 14 hours per week. The point also I want to make is, notice that it always refers to the hypothesized number is always involved in the description. That original sentence where we got the hypothesized number from, in this case 14 hours per week, needs to also be in that final sentence somewhere. The final sentence is all about trying to explain what it means to reject or not reject, and you gotta relate it back to the hypothesized sentence with the hypothesized number. Here's another one. Again, did I pass it? I jumped forward, I may have passed it. Oh,
There's a lot
show
of
me one
different
more,
ways,
again.
but-
Show me two more. Here we go. This means that the magazine's claim that fewer than 40% of the households in the United States have changed their lifestyles because of environmental concerns is not justified by the sample data at 5% significance. This sounds like they couldn't reject the null hypothesis, that they were trying to say that fewer than 40% of the households, but the evidence didn't allow them to say that, so they couldn't reject it. They can't make the claim less than 40% of households, is how I read it. Therefore, we do not reject is right there above it too, so that kind of gets it away. But do you see how it's referring back? It referred to the proportion of household changing their lifestyle, 40%, so that was the hypothesized number. The hypothesized number is always in that final sentence. Here it is again. At 10% significance level, and I'm not, you don't always have to mention the significance level, but you know, it seems like that's done a few times in here. At 10% significance level, the proportion of adults who favor marijuana legalization in Ohio differs from the national proportion of 57%. Again, it's using that hypothesized proportion of 57% in there. I want to go to problem 68. You know what I'm tempted to do also? Where is 68? There it is. This is, I think, one of the toughest problems to write the hypothesis for. It doesn't jump out at you as though it uses words instead of numbers. But don't forget, you gotta write a hypothesis that has numbers. So, where are we? I think we're in the proportion. So I'm just gonna erase this. We have the two proportions here, the null proportion, the alternative proportion, either equals, not equal to, greater than, less than. Let me read to you. 68. A politician claims that he is supported by a clear majority of voters. In a recent survey, 24 of 40 randomly selected voters indicated they would vote for this politician. Is the politician's claim justified at 5% significance? What do you think the hypothesized number is? You know, here's the hit. Majority of voters. Not 0.6, what is it?
51%.
Darn close. Actually, 50% would be it. Majority is anything above 50%. So what we're trying to say is, the alternative hypothesis, and I may be wrong, let me make sure I got this right. We're trying to prove, or really he's trying to prove, that he has the majority support, which is more than 50%. So I'm putting this at more than 0.50, which covers everything above 50, but not equal to 50. So the null hypothesis would be, no, you're wrong, you don't have above 50%, instead you have less than or equal to 0.50, which includes being equal to 50%, so this is like 50.0001, he has the majority. Now, it's a percentage, it's not how many voters, so it could be.
For the quiz, will we be solving for both the mean hypothesis and the proportion? Or just-
Some of them will be proportion, some of them will be mean, so sometimes you're using the word proportion or a P here, sometimes you're using the word mean or that little symbol for mean.
And we'll let, like, when we're doing the quiz, like, with the paragraphs, the problems tell us specifically, like, mean or proportion?
No, not at all, you gotta read this one. A politician claims that he is supported by a clear majority of voters. You gotta say, what does majority mean? This is what makes it higher, and you go, oh, 50%, over 50%. Well, that's a proportion, plus there's no standard deviation there. So that kind of tells you it's proportion also, if you use the word proportion there on your
So yeah,
hypothesis.
if there is a standard deviation, we're
Then
never
you know,
really solving.
then you know to use the word mean here.
We do put mean?
Yeah, if there's a standard deviation, population or sample, use mean.
Okay.
So does the 24 out of 40 kind of just mean nothing?
No, it does mean 24 out of 40 is our sample proportion. So that's what we're gonna compare to the 50%, which is gonna be 0.49 or 48 or whatever 24 divided by 50 is. 0.6 is, look at 0.6. So now we have our sample proportion. So let's say we're gonna do our test statistic. This is gonna be 0.60 minus 0.50. This is gonna be 0.50 times 1 minus 0.50. And the sample size is 40. There it is. What?
So you said that the 0.50 is the.
Yeah, because
proportion and then
here's our hypothesize, the key word there, supported by a clear majority of voters. This is what makes it so hard. It doesn't say supported by over 50% of the voters. It says majority of voters. You gotta read into it and go, oh, majority means over 50%. So that's why I went ahead and put 50% here for our hypothesis. All because of that word majority. I'm not gonna be that tricky, at least I don't think I'm gonna be that tricky. I should be that tricky, but I don't think I will be. So it will be pretty much like all these other problems where it gives you the percentage instead of the word majority. But I just wanted to give you an example of how tough these can get. What you should have at least recognized, there was no standard deviation in that problem. Real quick, did it give us a significance on this? Where did it say after our significance? 5% significance, hang on now. Hang on, I gotta think about this. Are we doing Z or T on this? This is a Z, this is a Z problem. 5% significance. Is it one tail or two tail? It's a one tail. Let's go to our notes, hang on. Boom, critical value, almost there. Critical value, one tail. Okay, what goes in parentheses? What is it?
Oh, it's a 95.95.
There you go, 0.95. It's just the confidence because it's a one tail. It says 5% significance, so we would put 0.595 on that one. Well, this would give us our critical value. If we were using the critical value approach, we would compare our test statistic to the critical value, and our test statistic ends up being inside the plus and minus critical value. Therefore, can we reject or not reject? Not reject. If your test statistics is inside those critical values, you can't reject. Boy, you guys, we've gone through a lot of examples. Now, this is where we're supposed to talk about type 1 and type 2 error. But here's what I want to do, because of this being a snow day, when they're shutting down the school in a matter of 22 minutes or 24 minutes here. We'll already canceled the in-class assignment because the other class isn't even meaning to do the in-class assignment. So there's no in-class assignment today. I'm posting it, and just after we leave, I'm posting the in-class assignment. So if you want to attempt it, I'm gonna wait till tomorrow to post the answer. But you don't hand it in. But I'm gonna have it there for you to attempt it. It's a good in-class assignment because I'm asking you to solve a proportion problem with all three approaches. This will really test you to see if you can do all three approaches. If you can do this in-class assignment, then you can do every one of the homework problems. Or if you've done the homework problems, this in-class assignment will be easy for you.
Professor, when do we compare the hypothesized mean to the intervals? Is it when we're solving for Z?
Well, if this said solve using the confidence interval approach, that's when you're gonna get that upper and lower interval, and you're gonna compare the hypothesized 50% to see if it fits or not.
What about the test statistic to the critical value?
We wouldn't use the critical value on the confidence interval approach, but we would definitely use the critical value on the critical value approach. Oh, I'm sorry, yeah, you gotta do the critical value on the confidence interval, because you gotta use it to find the upper and lower. So you definitely gotta use the formula for the critical value on the confidence interval. I'm sorry, I don't, tell me your question again.
So when we're doing the confidence interval, okay.
We're definitely doing the critical value, the Excel equation to get that critical value.
Okay, and then when we're comparing it to the hypothesized mean or the other?
Yes, to see if the hypothesized proportion fits in it or not, yes. Upper or lower.
That's only for the proportion and the p-value. Well, no, not the p-value, I'm sorry, the...
Critical value?
Yeah.
Yeah, but it's the same thing though with, if you have the mean with the population standard deviation and the mean with the sample standard deviation, if you gotta solve those using confidence interval, you're comparing the hypothesized mean to the interval to see if it fits. Same concept. This one's just comparing the hypothesized proportion. The other two are comparing the hypothesized mean. Now that's why this is why I think this was an important, this is why I put this together, because I wanted to show all three confidence intervals, like she said, is using the critical. This one's using critical Z, that one's using critical T, that one's using critical Z. Here's the right-hand side of each one of them. there's what to start each one of them. The only thing that's not on there is what do you compare, but every one of the three of these, you're always comparing the hypothesized number to see if it fits or not. That's the same for all three of those. You compare the hypothesized number to see if it fits. If it does fit, you can't reject. If it doesn't fit, you must reject. Boy, you guys, you got so many tools to use. You've got to ace this stuff. Go ahead, Claire, and I'll come up here.
Just to clarify, so for confidence interval, we're not finding the test statistic.
So that, yeah, you don't have to calculate a test statistic for a confidence interval. You only gotta find the intervals after you get that critical value to fit into that confidence interval. Don't need the test statistic. That's the number one mistake most people make on confidence intervals. They're so used to starting with the test statistic, they'll do the test statistic and then realize they didn't even need it, and then it just wasted a bunch of time.
So, for confidence interval, my question was about that too. So we're not doing any Excel equations when we're using the confidence.
Oh yeah, you gotta do the Excel equation to get that critical value. To get that number there, all three of these, you're gonna have to use either the, one of those two, one of these two equations right here. That's why I put them down here, matter of fact. You've gotta use one of these two equations to find the critical value to fit into those three equations, so you do have an Excel. Every problem has an Excel involved one way or another. And don't forget, don't let me trick you. If I'm asking you to find the confidence interval using Excel only, you know it's not even either of these equations then, it's that confidence equation. Quiz is a week from today. We got questions can be answered on Monday too.
So only p-value and critical value we find a test statistic.
Say again, only p-value and critical value.
We have to find a test statistic.
Right. He said only p-value and critical value approaches, do you have to find the test statistic, and that is correct.
And that's for population standard deviation.
For all three of them.
standard deviation, and
All three of them, same thing, yep. All right, I just want to introduce you to type 1 and type 2 errors, so you know what they mean and what they are. But we will not go over the calculation for type 2. That's time consuming, and I'm going to save that for Monday's lecture, which will be good because that will kind of put things in perspective. But there will be a question about type 1 or type 2 error on your quiz. So that's why I want to make sure you get these. Type 1 is very easy. Here's the deal, okay? Think about the bell curve. Boom. Right there. And you have those critical values, are always evenly distributed on each side of there. Okay, there and there, there's the critical values. This is the minus, this is the plus critical value. In these tails is our significance. And a type 1 error is when you reject a null hypothesis because your sample ended up being in one of these tails if it's a 2-tail or in the appropriate tail if it's a 1-tail. But if your sample ended up in the tail, you're gonna say, oh, I reject the null hypothesis. But then, let's say we're able to get the population information and we realize, oh man, our sample was off. We should not have rejected that null hypothesis. That's a type 1 error. So let me repeat it. When you reject a null hypothesis and it should not have been rejected, the null hypothesis actually ends up being true. That's a type 1 error. The probability of a type 1 error is always whatever the significance of the problem is. Everybody hear that? The probability of a type 1 error is always whatever the significance is.
Can you repeat that one more time?
Okay. A type 1 error is when you reject a null hypothesis, but you should not have, and the null hypothesis ends up being true. And the probability of making a type 1 error, making that rejection when you shouldn't have rejected, is equal to whatever the amount of significance of the problem is. If it's a 5% significant problem, that means there's 5% chance of making a type 1 error. If it's a 90% confidence problem, that means there's a 10% chance of making a type 1 error. Whatever the significance is the probability of making a type 1 error. Even if you're given the problem in a confidence, you know you can convert that to significance easily. You got it? All right, now, a type 2 error is when you should have rejected a null hypothesis and didn't. You said, oh, we cannot reject that null hypothesis, but we should have. Now, I'm gonna just quickly, don't take any notes on this, this is what I'm gonna talk about on Monday, but to calculate a type 2 error, you gotta have, okay, there's 52, there was the hypothesized amount. Oh, it really is 50, but we didn't reject it, right? And we didn't reject it. So you're gonna go ahead and take, I'm gonna jump forward. You gotta take 52 and find the upper and lower interval. Then once you find that lower interval, you gotta pretend that's the number you gotta use with 50. So then you take the lower interval minus 50 as your new purport or your new mean. Define your z. Then you gotta look up your z to get your probability, and that probability ends up being the probability of a type 2 error. But I'm going over that on Monday. That's what we're skipping today to get out early because today's a snow day. Now let me review. I want to tell you, slide 11. Slide 11 is a good slide to look at because if you're being asked, hey, what is a type 1 error? You can see it right there. A type 1 error is where you rejected the null, but the null hypothesis is true. Look at how it rejects null hypothesis true. Go up here to a type 2 error. It did not reject the null, and the null is false. Did not reject null, and the null is false. So if you're looking at it, which one is which, type 1, type 2, this is a perfect slide that kind of defines, just kind of match it up. All right? Let's go home before we get snowed in. Do your homework, get it in on Monday, I'll see you then. If anybody forgot to sign in on your way out, please.